Bismillahirrahmanirrahim. Welcome to the second part of the 21st lecture of the statistics and probability theory. We will continue with the topics simple linear regression and correlation. So we will going to study now the fitted regression line. As we have discussed in previous part that we have a regression model and we are discussing a simple linear regression model which is y is equal to beta naught plus beta 1 x, as this beta naught and beta 1 are unknown population parameters, and if this is non-deterministic, so the term epsilon will come along with this, as epsilon is the error term. So what we will going to do now, we will going to estimate this beta naught and beta 1 with the help of the sample data, which would be estimated or predicted value for y observation I when we estimate beta naught and beta 1, and we substitute these values here. This would be y hat, this would be the estimate of the regression intercept. This beta 1 is the estimate of the regression slope and value of x for observation I. So this one is the estimated line, this one, or you can say the fitted regression line. This line is called the y on x. We are regressing y on x. So this is called the y on x. Let's suppose if you want to regress x on y, so it would be x on y, and the line would be x hat is equal to c, as c is the intercept, plus d, and this one is the y. So this is the line, fitted regression line for x on y, and c or d are the estimated values for the parameters of the regression line x on y. So as you know that this is the scatter plot, and we have plotted the we have drawn the line of regression on the data points to capture the behavior, but the line could be, this regression line could be best fit or it could be worst fit too. As you can see from this that these are the data points and this line is passing through this area, and the distance from the data point and line is not very much high. And if you see in this particular graph that this line is passing through this way, and these are the data points, and as this is the increasing trend, whereas this is the decreasing trend, just for the information. So now the difference between the line and the data points are very high, as you can see from here. So this one is not a good fit. So this is the bad fit, and here the deviations are minimized. So this is somehow a better fit. So if you want a good fit, so the distance between the line and data points should be minimum, and we should minimize it. Then how to estimate the parameters of regression line? So this is the question here, that what strategy or which method we should adopt so that we could minimize this distance and we get the better fit. For this purpose, we use the method of least square. Method of least square is the phenomena, or it is a method which is used to find out the estimates of the unknown parameters beta naught and beta 1 in case you are regressing y on x, so that you will get the best fit because they will give you the estimates of the parameters which have the minimum variance. So in method of least squares, we minimize the sum of square of residuals. What are the residuals? Residual is basically is the difference between the true value and the estimated value. As you can see from here, this one is the true value. This one. These are the true values. And line is saying this is the value. So this one is y and this is the y hat, and this difference, this is the y hat, you see from this graph, and this is y. So this difference is basically up small e, as we can't find out the error component on the whole, so we use this is E1. Epsilon is for the error term and this E1 is for the residual. So this is Y1. Similarly for this case, this would be Y2 hat and this is Y2 and this difference is apps. This difference is E2. So we can't find out the error term and it is unknown, so we use epsilon, small e instead of epsilon, which is the difference between the true value or observed value and the estimated value. So what we do for the use of the method of least square, we minimize this sum of square of residuals. Summation I is equal to 1 to n e I square, which is equal to yi minus y hat whole square. So as we know, y is hat is equal to b naught plus b1x. So we substitute this value here, square, and we minimize it by differentiating this with respect to the unknown parameters. That is, first we differentiate this particular summation ei square with respect to beta naught and equate it to 0, and then we will again differentiate it with respect to b1 and equate it to 0. In the result we will get these two normal equations, which are these are two normal equations, two equations, two unknowns. By simplifying this, we will get these values of beta b1 and b0. So this is b1. This is the way to estimate the b1 by using the method of least square, and this is the way to estimate b0 by using the method of least square. So this is the way to find out the estimates of the unknown parameters by using the method of least squares. In case of x on y, let's see, this is, so the parameters would be x is equal to c plus dy, again by using the method of least square by minimizing the sum of squares of residuals, which will be summation x minus x hat. This is the true value and this is the observed value, and square I is equal to I is equal to 1 to n. So this will give us d is equal to, by simplifying it, the normal equations, n into summation n into summation x y minus summation x into summation y whole divided by n into summation y square minus summation y whole square, whereas c is equal to x bar minus d into y bar. So by substituting the values in this two formulas, we will get the estimates of the parameters, and we can fit the line by, if when you substitute these values here, this would be x hat is equal to c plus d into y. So here is the numerical example. Fit a straight line to the x and y values in the following table. So this is the values of x, 1, 2, 3, 4, 5, 6, 7, and this is the values of y. So for the requirement of the formula, we will calculate all these things, and we will going to fit the regression line y on x. For this purpose, you need to find out these two values, v1 and v0, and we need all these calculations. Summation x is obtained by summing all this column. Summation y is obtained by summing this column. Summation x into y will obtain by summing this column, and summation x square will obtain by summing this column. So these are all calculations. By substituting all these calculations in the formula, which is here, you will get v is equal to 0.83929 and v0 is equal to 0.071411. By substituting the values, this is the value of v0 and this is the value of v1. So this is why I had which is this. This is the estimated line, or you can say this a fitted line. So this is the practice question. Fit regression lines y on x and x on y to the following data for the purpose of the practice, and find out what are the values of the estimated parameters.